Students, so today I'm here with some more concepts. There's a question. So the question is, there are capacitors, 2 microfarad, 3 microfarad, 3 microfarad, 2 microfarad. They're connected with a battery of 10 volts. And the question is that what amount of charge will flow through the switch, that is from A to B or B to A, when switch is closed, right? So today I'll be clearing the concepts that how to calculate the flow of charge through a particular branch in the circuit when you're closing or you are opening a switch. Okay, so now see, we proceed here. You see, your first step will be what? In all such questions, it's a general strategy. The first step is what? Find out the charge and polarity of each capacitor. Initially. So the meaning of initially is what? When the switch has not been closed, what is the charge and polarity on each capsule? You'll have to find. So you see, when switch is not closed, these two are in series. These are also in series. So the capacity of upper branch will become, they are in series, so C will become C1, C2 upon C1 plus C2. So that will be 2 into 3 upon 2 plus 3. So that becomes 6 upon 5, 1.2 microfarad. So the capacity of upper branch is 1.2 microfarad, and the capacity of lower branch is also what? 1.2 microfarad. So across this branch, you have a voltage of 10 volts, and across the lower branch also you have a voltage of 10 volts. So the charge on each capacitor in the upper branch will be Q1 will equals to Q2. This will be the charge on both the capacitors, Q1 and Q2. This will be equal to CV. So that will be 1.2 into 10. That's what 12 microcoulombs. So the polarity will be like what? Polarity will be positive, negative, positive, negative, positive, negative, positive, negative. In each capsule in the upper branch, Q1 equals Q2 equals to this much. That will be Q3 is equal to Q4 will be equal to what? 12 microcoulombs. Right? Each capsule will have equal charge because they are in series, so both will have the same charge. And that same charge will be what? That will be the total charge on this branch. This is the total charge on this branch. One more thing here, we calculate that what is the total charge on the system? The total charge on the system is 24 microcoulombs. Because see, this branch has 12 microcoulomb charge. The lower branch also has a 12 microcoulomb charge. So the total charge on the system is what? 12 plus 12, that is what? 24 microcoulombs is the total charge on the system. This is clear? So initially what you need to do, mark the polarity of each capsule before you have closed the switch. Before that, find out what is the polarity, what is the charge on each capsule, and what is the total charge on the system. Right? There's the first step. Now, second step is what? When you close the switch. When you close the switch, then see how the figure becomes. The figure becomes like this. So you see, it is obvious that these two capacitors become in parallel. These also become in parallel. Capacity of this 2 3 microfarad, 3 microfarad, 2 microfarad. Capacity of this becomes what? Polarity will remain same, positive, negative, positive, negative, positive, negative, positive, negative. And the capacity of this first loop becomes what? They are in parallel, 2 plus 3, 5. Capacity of this also becomes 5. I make another figure here. 5 microfarad, 5 microfarad, 10 volts. 5 microfarad, 5 microfarad, and this becomes what? 10 volts. Right? So the voltage across each will be equal because they are in series and they have the equal capacity. So the charge across this will be how much? 5 volts across this. So the charge on this will be what? Here I write Q1 dash and Q1 3 dash. So this was 1, this was 3. So this is what Q1 3 dash. This Q2 4 dash. So Q1 3 dash will be equal to Q2 4 dash will be equal to what? This will be equal to how much? This will be 25 microcoulombs. Do you understand this? I then find out the total capacity. Total capacity is what? 5 by 2. So the total charge will be 5 by 2 into V CV. So 5 by 2 into 5 by 2 into 10. 50 by 2. That is what? 25 microcoulombs. Or do it in this way. This 10 volts, so 5 volts will be across this. So across this will be 5 to 5, 25 microcoulombs. Across this also 25 microcoulombs. And then now the total charge on the system. Total charge on the system Q dash is equal to 25 microcoulombs. The charge on each is 25 microcoulombs. So the total charge on the system will also be what? 25 microcoulombs, right? These are the basic calculations. What? First of all, in the initial state, you have calculated that what are the polarities and charges on each capacitor and what is the total charge on the system. Then you calculated what? In the final state, when switch has been closed, what is the charge and polarity on each capacitor, and also what is the total charge you calculated this. Right? Now, you have to relate the previous figure from this figure. First of all, one thing becomes clear that battery must be supplying an extra charge of 1 microcoulomb. How? Because see, the total charge is increased by 1 microcoulomb. Total charge is increased by 1 microcoulomb. That means what? Initially it was 24, now it is 25. So that means battery must be supplying 1 microcoulomb extra charge. So the total charge on the positive plates is more than earlier. So from the positive of the battery, 1 microcoulomb extra charge will come. This one comes. Now see, the charge on this is 25. And this is made up of these two capacitors in parallel. So out of 25 microcoulomb charge, how much will be on this capacitor? In the parallel, charge distributes itself in the proportionality of the capacities. Or in the other way also you can directly calculate. This 5 volts is across this. So the 5 volts will be across this and 5 volts will be across this. So the charge on this will be what? 10 microcoulomb, 5 into 2. And on this will be what? 15 microcoulombs. Let's write that. It is what? 10 microcoulombs. It is, I'm writing only the number, not the microcoulomb. This 15. Similarly, Charge on it will be 15. 5 into 3, 15. And charge on it will be what? 10. Charge on it will be what? 10. Is that clear? Right? So you see, total on it is what? 25. 10 plus 15, 25. This 15 plus 10 is what? 25. This is clear. Now you have to relate that in what way the charge should flow so that the charges from this condition, like here, the charge was what? 12 microcoulombs. It was 12. It was 12. It was 12. It was 12. So you will follow the law of conservation of charge. In following the law of conservation of charge, how can the charges be modified on different capacitors according to this 12, 12, 12, 12, right? So you see now, you see, now it is 10 here, 15 here, right? So what I do, I carry this charge 2 microcoulombs here, plus 12, minus 12. So I carry plus 2 microcoulombs here, plus 1 comes from here. So from here, this comes out, microcoulombs comes here. The direction in which I'm making the arrow, that is the flow of positive charge. 2 microcoulombs and 1 microcoulomb this one. So that becomes what? 12 plus 12 plus 1 plus 2, that is what? 15 microcoulombs. Now here, what is the meaning of law of conservation of charge? Is plus 15. Earlier it was plus 12. So minus 3 microcoulombs charge will be developed. More charge will be developed by the induction. This will become plus 15. This will become minus 15. So to develop the minus 3 microcoulombs more charge, plus 3 microcoulomb charge will flow from here. Plus 3 microcoulomb charge will flow from here. And that I carry to this side. This charge I carry to this side. This is clear now? And this plus 3 microcoulombs I give to this capsule. So this becomes what? It was plus 12. Now plus 12 plus 3 becomes what? Plus 15. This becomes what? Plus 15. Look at this. What is the law of conservation of charge? I didn't do only this. The plus 15 comes here. It becomes minus 15 here. Then I don't carry the plus 3 charge onwards. I need to carry that plus 3 charge. Then only the minus 3 charge will be developed here. So plus 3, it's all in the microcoulombs. Plus 3, this plus 3 microcoulombs comes here. Here becomes minus 15. So plus 3 will flow from here. Right? Now see, it is plus 10 here now, but this is minus 12. Because earlier it was minus 12. Plus 12 was there, but plus 2 microcoulombs comes here. So it is what? Minus 12. Now what I do, minus 2 microcoulombs charge. It is a minus 2. I carry here. Minus. This minus 2 goes here. This downwards, it goes minus 2. This minus 2 comes here. So this will become what? It was plus how much? 12. It becomes what? Now this becomes plus 10. And we need to keep here plus 10. So this minus 2 will neutralize. So now see. So this what? Minus 2 comes here. It neutralizes that plus 2. So that becomes what? Plus 10. Its conditions are satisfied. Right now, what happens? This plus 3 microcoulombs, out of that plus 3, plus 2 comes here. So it's minus 12 initially. This minus 12 become what? Minus 10. And plus 1 comes here. So plus 1 microcoulomb had come out from the positive of the battery. Plus 1 microcoulombs goes to the negative of the battery. So the rule of the battery is what? As much charge will come out from one terminal, the same amount of charge of the same sign will come into the other terminal. So plus 1 microcoulombs comes here, plus 1 microcoulombs comes here. That means that you are not violating the law of conservation of charge. What charge you have taken from here, that charge you are giving back to the same point. And here also at every point, you see, we have never left a charge alone. We have never left a charge at a point or at a junction. Like see from here, -2 comes, this -2 comes here. So this neutralizes the +2 microcoulombs of this. It was +12 and it becomes what? It becomes what? +10. So this is what we say that we are following the law of conservation of charge. Right? Now see, now the question was from what charge comes from A to B or from B to A. So from B to A, positive charge of +3 microcoulombs had flown up and -2 comes down, which is equivalent to what? +2 microcoulombs is going up. +3 was going up from B to A. And because from A to B, -2 coulombs is coming down. So it is equivalent to what? It is equivalent to say that B to A, 2 microcoulombs more charge, more positive charge is going from B to A. So the total charge that flows is what? From B to A. When we say charge, it means positive charge. If it is negative charge, that will be spoken there in the option also. In the question, in the option also, it will be spoken that it is negative charge. So from B to A, the charge that flows is what? 5 microcoulombs. Deliberately, I write here plus. I write here what? Plus microcoulombs. But in the examination, they only write that 5 microcoulombs charge is flowing from B to A. So that means what? It will be the flow of positive charge, right? So students, it is one question in one concept of flow of charge. This concept can be made clear through 2 or 3 more examples, so that all kind of conditions, all kind of flow of charges, they do come in the discussion. And not only this, after this also there are many concepts in that. Like if they ask you how much heat energy will be generated, heat energy will be generated in the circuit when the switch S is closed. That is also a very good concept. So students, hope you understood this. Kindly write the comments in the comment box. You could understand this or not. And one more thing, if you want to join course in the physics in the offline or online mode, kindly comment in the comment box. And we have offline course for such good examples, for such concepts. We have the online course also. And when we are going to launch a video course also, in which in one class, there'll be around 6 to 7 such concepts and examples. So hope you understood and you're going to comment in the comments.